I want to like minimize that.
Should I minimize
The,
that? Is
the gray box on the screen share.
that
Yeah.
fine? That's fine.
Yeah, that's fine.
I'll put this up here.
Like,
You
yeah.
told me this.
I don't think I- so it's-
All right, guys. For those who are still coming in, we have this Google Collab up on the Slack, so make sure you make a copy of this so you guys can follow along with this as we go through. But yeah, today we're doing our Python and Git workshop. During this Google Collab, we'll go through the Python part, and then we have another presentation after for the Git part. But yeah, just for a show of hands, how many of you guys have done any sort of work with Python, just at all? Awesome. So that's a lot of you guys. That's great. So yeah, Python, as most of you guys know, is a very high level and very versatile scripting language. What's awesome about Python is that there's a low learning curve because a lot of the syntax is in human language. So it makes it pretty intuitive. The basic data types of Python, as you guys can see, we have ways to store numbers. We have ways to store true and false values through Booleans, and then ways to store text through strings. And Python's version of null is the none keyword. If you guys are unsure which kind of type an object is, you can always use the type function. And then yeah, Python also has some basic operations you can do with numbers and strings as well. So we have addition, subtraction, multiplication, division, modulo, and power. Power is not the caret. If you try to do a caret, it's going to give you something else. It's not going to be a power. And the order of operations are as you see in the bullet point list. So it makes it pretty intuitive. If you run these, you can see, I think the output box is already shown, but you can run it again and change the code to experiment if you want. In Python, variables are stored in a way that you don't have to say what kind of type that variable is, which makes it pretty nice. So you can reassign a variable of a different type throughout the code. As you see here at the beginning of these variables were integers, but then we change it to a string later on. And we can concatenate strings with a plus sign. As you see, hello there. Strings, like I said before, are a way to store texts and characters. It's with the same thing. You can use single quotes or double quotes. There's no difference as long as you start and end with the same thing. There's also these escape characters. So this \t does a tab, and this \n does a new line, as you guys can see. Python also has an f string. An f string is signified by prefixing the string with an f. And that allows you to put variables in Python code directly into your strings. And it's formatted pretty nice. All you got to do is wrap it around with the curly braces. So Python also has conditional statements. So these are your if statements. In this block of code, we use the random library to make a random integer from 0 to 5, and then we can see the different kind of outputs. I'll run it a few times so you can see different things. 3 is greater than 1, right? 0, 0. And yeah, in Python, we have a bunch of data structures, but these are kind of the main 4 that you'll be using a lot, which are given to you like automatically. Lists and sets and tuples are very similar, except lists are mutable, which means they can be changed throughout the program after that they've been like defined. Tuples are like lists, except they're immutable, which means they can't be changed after they were originally defined. If you want to change that tuple, you have to make a whole new tuple. There's also other minor differences, which you can see. Here's some examples of using these types. So a set, in a set, each like element in the set, it has to be unique. So if I try to initialize a set with 2 4s, for example, it's going to remove one of those 4s and just keep one of them, as you can see in the output. And yeah, in a tuple, you can't change this tuple after it was assigned in the beginning. You can still access it, which actually I show that down there, so you can see it down there. This is a for loop. A for loop is a way to repeat the same line of code, and you can add these conditions up here for how long the for loop lasts. Here, we're going through the length in list one. So list one has 1, 2, 3, 4, 5 elements. So you're going to go through it 5 times, and I is going to increment for each iteration in the for loop. So I can print I here just for you guys to see as well. It goes through each of the i's. There's a lot of built-in functions in Python for each of these data structures. So for lists, here are some common ones that I'm sure you guys will be using a lot. Python has a documentation if you ever forget these methods, and that's linked there, so you guys can go take a look at that as you need. Here's some more things you can do with these methods. So if you have this list, you can access elements with these brackets. Python is 0 index based, which means a 1 will actually give you the second element. A 0 would give you the first element. Pop will remove the element at that index. As you guys can see, I'm removing the second element or the first index. And you guys can read through the other ones. Some other another cool thing you can do in Python is a list comprehension operator. It's basically makes several lines of code all into one line of code, so it makes your code look more pretty and more concise. So for example, here's the syntax. So you could say actually say so this combines an if statement and a for statement all in one line. And it has a condition so that it will only save the elements that are less than or equal to 3. So here was list 1 originally, and then all in one line of code, we were able to break that down. The brackets out here that you see means that it's going to be a list. If you want to make it a set, for example, you just change it into the curly braces, and now it's a set. Which means, again, there's no duplicates, and it's going to be unordered. So, yep. Last thing I'll say for the basics overview of Python are functions. So functions are very helpful. You can store certain lines of code into this block by and signifying it with a def keyword, and you can call that whenever you want. You can pass in arguments to your function, and if you make an assignment in the like the definition of the function, like I do with this exponent, that means it's a default parameter, which means if I don't provide that parameter when I call the function, it is just going to make it that default thing. So here I just say power of 3, which means it's just going to be to the second power. But if I change it to something else, then it goes for that. So 9 and 27. So, yeah.
All right, NumPy. So who here has used NumPy before? All right, a couple of people. So NumPy is a way to build super fast arrays in Python because it's based on C. So it's built around C. And this will be crucial for managing millions of rows of data, which you will have to do probably in your projects. So to get started, you're going to want to import NumPy. So just type import NumPy as NP. And the way you make a NumPy array is pretty similar to how you make a list, but you would just wrap it around in, so for example, let's make a variable called list2, and you would just type np.array, and then your list, and then there's your NumPy array. So Fix that. There we go. So there's our array. We can print it out. There we go, array. So there's a lot of ways to actually make these arrays. So NumPy comes with many functions that are going to be useful to quickly generate these arrays. So we have np.zeros, which you can just specify the number of rows and columns, and it'll generate you an array of all zeros. And similarly, you can do the same thing within an array of all ones. You just type in np.ones, and then you put in a list, and it will give you the, in this case, a 3x2 array of ones. Another interesting thing with NumPy is that you can actually easily generate a sequence of numbers. And the way you do this is you do np.arange, and it'll print numbers starting from 0 just before this number. So right now we have 10, we could change it to 100, whatever you want. All right, and then another interesting feature is np.linspace, which will generate a specified amount of values between an interval. So here I'm telling it to generate 5 values that are evenly spaced between 0 and 10. And so if we print this out, you'll see that we get these values. So 0, 2.55, 7.5, 10, and that makes sense because they're all evenly spaced out. Next, another important thing to know is how to make a NumPy array 2D. And the way you do this is you simply add more lists within your np.array command. So it would just be np.array, parentheses, and then you would just put in your lists, which we have above as well. Right, so another important thing is to know what even is your array, like what is it made out of? So here we have some helpful member variables we can call on our NumPy array. So shape will tell you how many rows and columns it has. Size will tell you how many elements it has. So in this case, we have 1, 2, 3, 4, 5, 6. So it got that right. And we can also check the data type, which will be important because you can be storing, I guess in the future, when you're using Pandas, you can be storing names within an array. But in this case, we're storing numbers, so ints. Right. And we have more ways to alter our NumPy array. So there's a method called np.reshape, which we can call on our original TD array we printed before. As you can see, it's at the bottom. And what the reshape command does is, well, if you take a look at the bottom, you can think of it this way. So if you take a look at the flattened array at the bottom, what it does is it takes that 2 and then we step by 2 and then it arranges it in that way. So we have 3 rows, or yeah, 3 rows and 2 columns. So that is one way to change the shape of your array, which could be useful for managing data. Right, and another important thing is actually accessing the elements in your array, so indexing and slicing. And it's pretty similar to regular lists in Python, where we can use square brackets to access an element. So as we see here, we take our flattened array and and we put in 0, which gets us the first element, which is 1 in this case, as you can see printing out below. And you can also do a 2D access by specifying the row and then column, which we get the value 2, which is indeed in the first row, second column. Now, this is really helpful, and that is knowing the slice operator. And the slice operator is the colon right here. And the way this works is you specify the values, the start value, which is the very first value before the first colon. And then the next value is the ending value. So that's the index you start at. So we start at 1, and then we end right before 7. And the 2 here specifies that we step every 2 elements, which is why you see it's skipping 2 and 4 when we print the first print statement out. Similarly, you can use 2 colons to specify get everything in the array, or as a general shortcut to, so like in here we go from index 2 to the end of the array, and we do that by doing 2 : : Oh, another cool thing about NumPy is that you can do negative indexes. So this will get the very last element of your NumPy array. So that's just another cool feature. Right, so here's some slicing on a 2D array. It's pretty similar to 1D, except you would specify what row you want to access, and then in here we're getting the whole first column, because this colon means get every single element in the column, or the row in this case. And similarly, we can do the same thing for the column. And as you can see, we can also incorporate the slice operation into our 2D array as well, which is useful. Right. Here's something really interesting, and that is conditional indexing. So we have a way to specify, like an easy way to specify, if you wanted to get all values greater than 3 within your NumPy array, all you would have to do is put in your array and then put the greater than sign and 3, and then it will return you all the elements that are greater than 3, which is helpful. Right, operations on arrays. So just like regular primitive objects where you can add them together, you can also do this to arrays. So here is adding 2 arrays together. As you can see, it adds every single element with each other. So we get 5, 7, 9 because 1 + 4 is 5, 2 + 5 is 7, and 3 + 6 is 9. And similarly, you can do other basic operations like adding, subtraction, and taking the square of the array. And at the bottom here, we have 2 more functions. So you can sum up all your values in the array, and you can get the mean with np.mean. Technical difficulties. We'll be with you shortly. This is regular. Don't worry.
Just another lesson in tech.
Oh, okay.
To make anything work, you want to turn it off and on again.
It's actually back. So. Yeah, so since happening to
Might like speed up.
That's what that is.
yeah, but
Now, that's not there.
just add 100 seconds to the front.
I'm trying to like hard reset it.
Keep talking if you want. It'll be on.
That's true.
Yeah, maybe just keep talking because they have it in front of them, so it's fine.
All right, so does everyone have the document in front of them so you can still follow along?
Yeah.
Okay, great.
Let's
Yeah. Okay, so we just covered operations on arrays. So let's move on to actually combining these NumPy arrays together, because you're going to be merging data sets all the time. So you're going to have to know how to bring two arrays together. And so if you go to the first line, we go over transposing an array, which is just taking all the rows and making them into columns. And then the way you concatenate arrays is by calling np.concatenate and by inputting your first array and then your second array. And then that will put them all together into one big array, which is in the shape of a list. You can also split the array. So, and the way you do that is by using np.split, where you can just input the array you want to split, and then the element index you want it to split at, and it'll delegate the split array into two variables, which you can then access and use for your own use. Okay. Next, we're going to cover how to generate a random array of numbers for you to do some possible statistical analysis with. And the way to do that is by calling np.random.rand and specify the amount of rows and columns. So in this case, we're telling it to make 10 rows and 2 columns of random numbers and put that into data. And following after that, we want to find the mean of this random data, which we can do by using our np.mean command, where the first parameter is the data, your random numbers, and then the second parameter is actually part of the next presentation as well on Pandas, which is axis equals 0, where you can specify if you want it to do the means for every column or every row. So it's important to be aware of the axis you're taking the mean of. So because in this case, 0 is take the mean of the elements in the column. But if I say axis equals 1, it'll take the mean of the elements in the row. All right, so let's leave the classroom. Let's do a real world example. So let's say that we were tasked with finding some daily weather observations for someplace, let's say Florida. And we were given 2 pieces of data, average temperature and the amount of precipitation. And what this question asks us to do is to use NumPy to perform several analysis and to find insights to this data, which we will have to do as data scientists to understand what we're dealing with. So in this case, it wants me to find the average temperature and precipitation for the year and the variance in temperature. All right, so let's get started. So since we don't have a weather data set, we will simulate one using the random feature in NumPy. And the way we'll do this is we'll have 365 rows, 1 for each day, and then 2 columns where you have the temperature column and then the precipitation column. So we can start clean with importing NumPy and then setting the seed to 42 so we all see the same random. And then what we're going to do is generate 365 values of temperatures for a year. And we're going to pull these random values from a normal distribution with a mean of 15 and a standard deviation of 10 degrees. So it seems like a reasonable way to calculate temperature for the year. And we're going to display it. And for our precipitation data, we're going to do something similar where we use that np.zeros function we used before to make an array of full zeros, except this time we're going to specify the amount of days we have, which is a whole year. And we're going to do something interesting with this. We're going to, with np.random.choice, choose 100 random spots out of the 365 elements and replace these elements to false, because this array is made out of Booleans. So it's either true or false. And this true or false means whether it rained in that day or not. So we'll go through 100 of them and replace it and say that, oh, it didn't rain that day. And then we'll just randomly get the amount of rain that happened on that day by multiplying it by a random from another exponential distribution. It doesn't really matter what distribution you use, just one that matches the situation. So cool, we have that data. And now it's helpful to have this in one array so you can easily modify it and work with it. So you can do that with np.column_stack and then just put in your first array and the second array. So in this case, we have temperatures and then precipitation. And we're going to answer the first analysis, which is to find the average temperature and precipitation. And the way you do that is, well, we're just going to have to run the mean on every column. And we do that here by using the slice operator to get the whole column and then get the first row, all the columns in the corresponding to the first row, because that's where we store temperature. And we find that it's 15.1 Celsius. And likewise, if you uncomment this, we can get the same average for precipitation. And we find that it's 1.48. Right, so the second thing asks us for the variance, which you can get with np.var, which is just more statistical functions from NumPy, which get the variance, which we find is 89.63. And we can also run a conditional combined with np.sum to find the amount of days that had more than 5 millimeters of rain. So that's helpful if you want to know like what days are the days in the year where it rains a lot. And here at the bottom, we have extra practice for those inclined to do it. So if you want to do this at home, you are fully welcome to. But I think it is a great practice opportunity to understand NumPy and all of its specifics.
Yeah, so now we're going to go over some of the basics of pandas. If you're participating in the data dive, this is going to be super useful, as you may know. So similar to NumPy, we're going to start off by importing pandas as PD. Where this becomes useful is when you're actually taking in your CSV. So if you find a CSV online, just go ahead and copy that URL into there with double quotes, and you could print the data frame just with DF. So this here is the data set that many of you probably use to see the quality of teachers for each course, or like how easy certain humanities classes are when you're registering for classes. So in pandas, you have a bunch of different methods that are going to be super useful to start exploring your data set and, make some initial observations. So you could check out the first however many rows just by doing like df.head 5. Oops, n equals 5. Oops, that's right. So you could check out the first few just by doing df.head. I cannot type right now. All right, so you can see this generated the first 5 rows. In Python, you start at the 0th index. So although it's the first 5 rows, you're just doing 0 through 4. Likewise, we have df.tail, as that sounds like it gets the last 5. So we have 69,000 courses here. You could do a sample of the courses of the rows, so you can get a random set of rows. You can do this in 2 ways. You could do it by a specific number. So let's say I only want 5 of these courses. Then I just do n equals 5. But if you're looking more like proportionally, I can get, here's 50% of the rows. So frac equals 0.5. Likewise, you could select rows by position. So maybe if you only want to see the first, or like somewhere in the middle, let's say like I only want to see 10 to 20. There's that right there, 10:20. This one is inclusive of the boundaries. And this one's super useful here. You could check out the largest and smallest rows for certain categories. So if I'm looking around and I'm wondering what the highest number courses here offered at Illinois, you can just do n largest. And then you have two parameters that you pass in. So the first one is the number of largest ones you want to see. So I want to see the 5 largest courses, like the numbers. So first parameter is 5, and the second one is number. It's super important here that the N is capitalized. You have to copy it exactly how the data set shows. Because here it says number with a capital N, so that's super important. And you can see here, obviously we get the law courses offered here because we have a law school here. Also super helpful are conditionals to sort of subset the data. Some of you may be familiar with Java or C++ from the CS courses here, which use like double ors or double ampersands. But in Python Pandas, you just use the 1 vertical line or 1 ampersand. So just exploring the data set here, I want to see all the rows where exactly 100 students receive an A. So what I'm going to do here is df, and then in square brackets, df.a equals, and exactly equals is 2 equals right there. Exactly equals 100. And you can see in the A column, they're all 100. Another way of doing this, if you have a column name that's more than 1 word, like course title, you can't do the dot course title. You have to go like this. Obviously, there's no course title that equals 100, but this would work if you did like that accomplishes the same thing. So now we're going to do some combining, some more complex conditionals. So I want to find all the graduate level classes. Those are between 500 and 599. So I'm going to go into df.number. And then I'm going to say it's greater than or equal to 500. And if you're doing a complex conditional, make sure that you have both conditionals in parentheses, or else it'll all mess up. But I'm looking for things that fall between 500 to 599. So I'm going to do and, because both conditions have to be true. And then here's the other parenthesis here, df.number is, let's just say, less than 600. And you can see here, I'm getting all these graduate level courses and none of the other ones. So I'm going to show you another, here's using the or conditional. So I only want to look at classes from 2022 and 2023. I'm going to keep the parentheses like last time. df.year equals 2022. This time I'm just going to use the or instead of the and, because I'm fine with either or. Something can't be from 2022 and 2023. So there we go. Something I could challenge you to do right now is try to find your favorite class at UIUC. I'll do mine. You could do this in several ways. You could do the course title. You could do the course title if you just want to do one conditional, or you could do a complex conditional by doing the course number and the subject. So I'm gonna do a complex one here. Remember, it has to exactly match. So I'm a math major. I have to make sure that it's all capitalized math and not lowercase there. And then df.number. And then there's all of my favorite classes, or same class, just different sections. Just one more thing to wrap up. If you're doing the data dive this semester, unfortunately, you're not going to find, or hopefully you don't find a data set that's already completely clean. We want you to, mess around with the data, see how to fix those NA values. And this can be done in several ways. There are more efficient ways than Pandas, like kth nearest neighbors. But I'm just going to show you some of the Pandas useful things here. So while I'm at it, the df.lock adds another row. So I'm going to name this row another row. And you can see here these curly braces. This is the value for each column. So I'm defining this another row. And in the year, I'm putting 2023. In the term, I'm putting spring. And then all these other ones are NA. But, you could continue on this list. setting each value to be whatever you like. But anyways, now I have this row with a bunch of NA values. I can't really do anything with it, like any analysis. First step is that we need to get rid of those NAs. So here's just a few ways to do that. If worst comes to worst, you could just fill columns with NA. So let's say in this case, fill columns with 0. So let's say in this case, I'm just going to say the course number is 0. You could fill this in with whatever. It could be like you could see here, this one, I do the mean. So I'm filling it with the mean of the course numbers rather than 0, which is probably more effective because otherwise you might be dragging down some of your values. So here it's 294. You could see I use the mean here, similar to NumPy. And in the parentheses, I did skip NA equals true because you can't add an NA value and divide by a number that just messed things up. And I use the round, which rounds as I'm sure you're familiar with, 0.5 goes up. So furthermore, let's go into the filling NAs for strings, for columns that contain strings. The course number is an integer, or in this case, it's a double, but the course title is a string, so I can't fill that with 0. In this case, I'm just going to fill it with an empty space. Of course, this isn't ideal, but much of your data manipulating in the data dive will have to do with, it won't have to do much with strings, but the ones with strings, you should give more consideration into. If worse comes to worse, you can't, you're having a hard time with this data, just drop it. It's not ideal because then you're just, getting rid of a value. It's not going to be a true representation of what you're trying to show. But that is always an option.
All right, we'll move on to Matplotlib. This is a data visualization library in Python, a very important aspect. You can do all your data manipulations with Pandas and Numpy and modeling later on, but in a scenario like your data dive, you want to tell a story, and most people are visual learners. So using visualizations is a very important aspect that you'll come up with. Okay, so similar to Pandas and NumPy, you have to import Matplotlib. The .pyplot is just a subset of Matplotlib, which is the most common aspect of it. PLT, again, just shorthand. When you're writing out your functions, it's just going to be easier for you to type. And that's just, industry standard. So move on to some examples. Here we have grade counts. We're staying with the same data set that we used before with the classes and grades. So we've listed all the grade types here, and we are adding a .sum function. So basically getting their cumulative count for every grade across all classes. So we're translating this into a simple bar plot. You can see your x-axis down here, all the relevant grades from A+ to F, and withdraw W. And the y-axis is the number of students. If you take a look here, it's 1e6. It's an exponent, so that's why the labels of the y-axis are from 0 to 1.2. So there's a lot of ways you can customize your visualizations, a lot of ways to play around with it. It's important to, here's the function for the bar plot, simple plt.bar, and you reference the variables you want to contain in your plot. So we're doing grade counts. On the y-axis, it's the index, meaning the names of the grades, and on the x-axis, and on the y-axis is the values. So again, just making your graph prettier and more readable for the viewer, you want to add a title. This is grade distribution, X label, Y label, and PLT show. You know, you don't exactly need it to show the plot. If you run the buff code without plt.show, it'll still run, but you'll have a bit of extra syntax. It's just a lot cleaner to run plt.show. This is probably an example of what you do not want to do while using Matplotlib. You can see the x-axis, it's all jumbled up, very unreadable. As a third party, you won't be able to make sense of what's happening in this plot. But again, in the same vein, it's a similar one to the above plot, but this time you're grouping it by the subject type. So if the x-axis was readable, it'd contain stuff like sociology, econ, stats. So do take care with using Matplotlib. I will say it does have a pretty steep learning curve, and some of its syntax can be a bit wonky. So you want to play around with it, but there are a few pitfalls you want to avoid. If you do have some prior experience with Python and Matplotlib, I would say that's another library called Seaborn. Give that a quick look, because that's a bit more intuitive and it's a lot more aesthetically pleasing. But for that to work, you need to have foundational knowledge of Matplotlib, since Seaborn builds upon Matplotlib. So this is probably a better example of what we were trying to show in the above plot. Instead of showing it for the hundreds of subjects there are, single in on one, stats, and show the grade distribution for that. Again, similar vein, you're selecting the features within your data set that you want to plot. Again, this is another cumulative distribution, and you're applying the same pretty much standard functions of a bar plot and your title, x-axis, y-axis. That's pretty much it. We showed bar plots here, but you can use line plots, scatter plots, box plots, all sorts of stuff. So please do, give that a quick look. There's a lot to play with, but, be sure to not get lost with what you're doing. We'll move on to Scikit-Learn. Just a quick show of hands. Who has worked with Scikit-Learn or heard of it? Okay. Just a handful of people over there. So Scikit-Learn is, when you're working with Python, it's essentially where the magic happens with machine learning. It's a comprehensive ML library that you can use for all your data analysis, and it's probably going to be the final or second half aspect, at least, of your data dive projects. It ranges from algorithms and functionalities, all from regression, classification, tasks in supervised learning and unsupervised learning with clustering and dimensionality reduction. I believe it also has some very basic deep learning functionality, but if you're interested in that, you should check out PyTorch or TensorFlow. I just want to, before we get into it, I just want to stress that Scikit-Learn is essentially a culmination and integration of everything that you've learned previously, or everything that you've done. You can do all your fancy models and stuff, but you need to start with your exploratory data analysis, using your pandas, using your NumPy, and get a good feel of the data that you're working with. Yeah, so I've showed here, this is not actually functionality from Scikit-Learn. You saw this before, but viewing the first 5 rows of data, if you want a bit of a refresher, it's good to take a look. Again, there's this info function. This is within pandas, but I want to stress the point that you want to get a good feel for your data before you move into the modeling aspects. So with this info function, you can see all the columns listed down that are in your data set. Basically gives a very concise summary. You have the number of samples and you have the data types. Over here, you have Scikit-Learn. This documentation is pretty good. They have given a sort of cheat sheet of algorithms that you can use within your data. Start off at the top and you can go to one of the 4 aspects it's shown. There's a lot more that Scikit-Learn has, but this is a pretty good starting point if you're not too familiar with the library or machine learning. So move on to some imports. Unlike Pandas and NumPy and Matplotlib, you don't simply just say import Scikit-Learn. In code, it's actually written sklearn. That's how it's written in code, but the library is called Scikit. You don't simply just write import Scikit-Learn, since it's such a large library. It has very many subsections of data of models and other types of functionality. So you want to specify what you're looking for first before you import. So over here, I've just ran a couple imports. I'll go over what these do. Train test split, linear regression is our model. I'm sure all of you are pretty familiar with what a linear regression is. If you're not, that's okay. And so just some evaluation metrics, R squared and mean squared error. So again, I mentioned before, Scikit-Learn, sort of an integration of everything you've done before. Right now, I'm selecting my features of how I want to model. I've just selected 3 features for my X or independent variables, year, term, number. This is basically just pandas. And for my Y, the variable I want to predict is students. So if we look here, I'm essentially using year. Yeah, I'm using year, term, and the number of this data to predict how many students are going to be in that specific sample. So if you guys see over here, year has an integer D type, term has an object D type, and number has an integer D type. So 2 of them are integers, 1 of them is an object. You guys need to make sure that once you get to your modeling stage, all of your data all of your data is in numeric format. Since we have 1 object D type for term, if we just simply run that in our model, we're going to get an error. The computer itself does not know how to read strings or categorical variables. So what we want to do is turn that into numbers. A simple way to do that is using pandas and using the get dummies function. So what this will do it won't do anything to the year or number features, but to the term, if it's spring 24 right now, or fall 22, it'll use its own way to convert that into numbers. This is a very simple way to do it. If you explore Scikit-Learn more deeply, there are a couple more methods that you are probably better. I'm just showing a very rudimentary example. There's something called one-hot encoding, or you can use various types of transformations. Within your projects, I would urge you to sort of check those out. So this is a very important aspect of your modeling and using Scikit-Learn is splitting your data. Say your data has 1,000 samples. You don't want to put all of that into the training of your model, because when it comes to testing your model and implementing it in real time, you won't know how it performs with that new data. So if you have 1,000 samples, say, good practice is to use probably 800 of it, 700 to 800. Usually industry standard is about 70 to 80% of your existing data to train your model, and use the remaining 20% to test it out. So basically you're just leaving aside a portion of your data to use at a later time, but you want majority of your data to train it. So think of it as, you guys are students yourselves. You have your textbook, you have practice tests. You want to learn the content yourself, but implement it in a real-time exam. It's a similar thing. It's called machine learning. The machine is learning what you're putting in as data. So yeah, an important function, this comes in Scikit-Learn, is train test split. So if you saw before, I set my independent variables as these three. And just take a note that I've used double brackets here in df. If you're using more than one feature, you want to use double brackets. Otherwise you'll get an error. So traditionally you split into train and test data sets. So if you have X and Y, you'll have 4 in total: X train, X test, Y train, and Y test. Make note that you want to do it in this order if you're going to use this train test split function. That's just the way how it's been programmed. And then specify X and Y of what you've set before. Over here, I've set it here. And okay, you can classify your test size. No, you can classify your test size as the proportion of data you want to use for your test set. I mentioned earlier, a good practice is to use 80% of your training data and 20% of your testing data. So over here, I've set test size as 0.2. You don't need to put train size, although you can. It's another parameter in the function. It's not required. You can do one or the other. And I put a random state. It's the same thing as NP random seed. If you set that before, then it's okay. But this is just another parameter in the model that you can if you want to. If you don't put a random state in this function or have set a random seed before, then whenever you run your data again and split the data, it's going to split it in a different way. It's going to take a different 80% each time. So if you want to reproduce your results, a good way is to set your seed. If you're going to use something like cross-validation, that's not really required. Don't worry if you don't know what that is. We'll probably cover it at a later date. Again, I've just checked the dimensions of the 4 variables I've set here. If we see here we're using a total of about just over 69,000. So 80% of that is about 55,000. And there's a remaining almost 14,000 for the test data. Again, for the Y, you can see that there's only one number. That's because your Y is only set as one feature. So it doesn't show up as a number. So I'm just going to use a simple, not a simple, but a linear regression model. There's tons of models available in Scikit-Learn, but what you want to do is when you import it up, when you import your model up here, you can add like, commas and stuff, logistic regression, if you're so inclined. Yeah, so what you want to do is call that model that you've imported into an initialization using brackets, and then you can move on to training your model. You're training the model, obviously you want to use the training data that you've set aside before. So xtrain and ytrain. To train your model, the function is fit. So I've set the model over here. Then I'm calling model.fit. That's to train your model, and to make predictions on your model, you want to create a new variable. I'm calling it LM_preds, linear model preds, and use the same thing, similar way, use a .predict function. For this, it'll ask you for what data you want to predict your model on. So that's going to be whatever test data that you've used, but only the X of it. So if you want to evaluate your model, I've just done two simple metrics: your R², which is standard for a linear regression, and a mean squared error. If you're familiar with how regression works, mean squared error is basically the loss function that you're trying to minimize and optimize. So same thing, I've called the functions up here, R² store and mean squared error. You can store them in a element and call the function. For this, you're going to use your y-test and the predictions on what you've made. So lmpreds and y-test, and I've printed it out. Very low R². If you guys saw, I hope you guys caught this. I was trying to predict how many students were going to be in a class just on the year, the term, and the number, course number. That's not, that doesn't really make sense. That's why I've achieved a very low R² score and a pretty high mean squared error score. So ideally, this shows the importance of, you want to make sure your data is in place. You can have your robust and complex models a lot more than the linear regression, but you want to have your data in place to make sure you're achieving fruitful results. And I think that's about it.
So that's it for the Python part. We're at the Python part went a little bit later than expected, so we're gonna do the Git portion in another meeting. There's not a lot to it, so it won't be too hard. But at this point, do we have any questions about Python in general, or the part that you guys didn't understand? Great. Yeah, so a part of why we did this is so that you guys could have this document to look back on throughout the entire semester. So make sure you use this resource and don't be afraid to ask the other project leads or other executive members for help as you guys need it.